So hello children, today we are going to start a new topic in maths called locus. So we will move on to, before we move on to see the syllabus and all, remember locus is a moving point under given geometrical condition. See, we will try to take an example of a circle. The first thing, you must see the syllabus. Syllabus says just three things. There are too many things in many books, but what you have to see, you have to understand the basic thing, and we have to do previous year ICSE paper, then you will get a clear idea as to what this chapter is all about. So remember, first example, the first thing in the syllabus is about circle. What is a circle? If you see it as a moving point, there is one fixed point, children, okay, which is called the center of the circle, and you take another fixed distance, which is the radius of the circle. If a point, this is the moving point, this is my moving point, which is at a fixed distance and at fixed distance from a fixed point. So if you see, if the path traced by this is a circle. So once more, locus of a point. Okay, so what is a locus? So remember, locus is a moving point, is the path traced out by the point moving under given geometrical condition. What is the condition? It is at a fixed distance from a fixed point. Fixed distance, that is radius from a fixed point. So if you see, it moves under that condition. Every point over here, this is called circumference of the circle. Every point is at a fixed distance from a fixed point. That fixed point is called the center. Okay, the fixed point is called the center of the circle, and the fixed distance is called the radius. Okay, so like I tell you one example. Long back, around 15-20 years back. So when you see radar where you see aeroplane, so aeroplane looks like a dot. Okay, so they see in the air traffic control, what we call ATC. So I remember long back, one of my favorite program was to see air crash investigation in National Geographic. They do investigation as to why certain crash happened. So you can see in the YouTube, you will get all the videos. So they were saying there were two planes. Somewhere in Charkhi Dadri, that place was called where this accident took place. So one plane was coming from Russia. Okay, it was coming, and one plane was flying up. These two dots were there. Okay, you can see in the radar. So the moving dot gives you the movement of the aeroplane when you see the radar screen. Radar takes that, you will see in physics what is sonar and radar. So 2 points were moving. So the person who was watching the screen at the air traffic controller, he saw, but because of some misunderstanding or communication problem, these two planes came head on in front of each other. So he saw these two dots coming together. Each dot represents an aeroplane, and the moving dot tells you the direction of the aeroplane. So suddenly what he sees, both the dot coming together and both dot vanished. Means what happens? They met with an accident. Both the plane fell down at a place I call Charkhi Dadri, and very sadly, I think all the passenger of both the plane. One was going from Delhi, I think, to Gulf countries. People were going to get new job, or those who had come back to India, they were going back to Gulf countries. And another, if my memory is right, was a Russian plane. You can check in the net. So what I am telling you over here is locus. So here the moving point is the movement of the aeroplane, and you see in an LCD screen now in the air traffic control. So first thing in the syllabus is that locus is a moving point, and children, you will see sometime teacher using word loci. L-O-S-A-I, I think is the pronunciation, and loci is plural of locus. So remember that chapter is named loci, and this is pronunciation, this is the spelling, it is plural of locus. So children, first thing I am telling you is that locus is a moving point under fixed conditions. So here the point is fixed and this distance is fixed. So let me explain to you this little bit more. One plane, I forgot to mention this word, was coming to land. It was coming to, I think, Delhi airport. If my memory is right, it was landing from Russia to Delhi airport. Another was it had taken off. So what we call takeoff. So it had taken off for the Gulf country. Okay. So one was going up, one plane was going up, one was coming to land. So there was actually, they maintained different altitude. You will see in geography, height above sea level. One was supposed to go down, another should have been. So there is a minimum distance between them is 1,000 feet. Okay, 1,000 feet means around 333 meters, if you see 300 meter like that. Okay, so somehow because of miscommunication and all, so I remember just since, because here we are talking about dot, so here these two planes were looking like dot, and sadly that air traffic control was saying that two dots, they came closer and closer, so they collided and both the dot vanished, means the plane got crashed and it fell down. So plane will no more be visible on the radar screen. So very sad thing, this is what he was saying. So now we move on to so why I said that story is to tell you that it's a moving point. So here I gave you one example here. I told you it's a moving point under fixed condition. This moving point, which is at a fixed distance called radius, and which is at a fixed from a fixed point called the center of the circle. So there are many other examples you see in any standard book. If there are, suppose, two lines parallel like a railway line, so we find locus of a point, moving point, which will always be at a fixed distance from both the lines. Okay, fixed distance. So suppose this is, suppose your 5.5 feet, if I remember, is distance between the two broad gauge railway line. Suppose it is 6 feet, so this will be 3 feet, 3 feet. So locus of a point which is always equidistant from two given parallel line is a third parallel line which is midway between the two parallel line. Opposite, if you have a single line, you have to find locus of point which is at a fixed distance, suppose 5 feet from both or 5 inches. So there will be two lines on both the side. Locus of point which is equidistant from a given line. So it will be a pair of parallel line equidistant from that main line. So this will be 5 centimeters, suppose this is 5 centimeter. So you can see the book, same thing about a circle. Actually this 2 point will come, when I come to this point 2 and 3, this is what is the main thing for ICSE. But since we are discussing about a moving point locus, loci is plural. So just I am explaining, and if you see any book, so to make topic interesting and to make you understand this concept of moving point called locus. So if a circle is there, we have to see, suppose two circles are there. So children, when two circles, okay, before the beginning of the chapter, any standard textbook, Concise, Samel Agrawal or any book, you will get all this diagram. Just I am explaining and making it plain to you to understand. Suppose there are two circles. They are called concentric circle, means children, they are circle with the same center, concentric. So suppose two concentric circles are there. You want to find locus of point which will be always equidistant from these two circles. So it will be a third circle in between. Locus of point which always be equidistant from the two given concentric circle will be a third concentric circle in between them. Now what about the radius? If the radius of this is 3 centimeter inside circle, if the radius of outside is 5 centimeter, then radius of this, what I have drawn, will be average of 3 plus 5 by 2, 4 centimeter. Once more, the radius of the inner circle is 3 centimeter. The radius of outer circle is 5 centimeter. They are concentric, means they have the same center. So you have to find locus of point which will be equidistant from both the circle. Means a moving point always maintaining equal distance from both the circle will be another circle whose radius is the mean of the two given circle. Lastly, there are other examples which I'll share with you in another video. Suppose there is one circle. You have to find locus of point which is always at a distance of, suppose this is a radius is 5 centimeter. So what we see, you find locus of point which will always be at a distance of 2 centimeter from the circumference of this circle. So here one circle above, I am using a black color, 2 centimeter here, means the radius of this will be 7, and 2 centimeter here inside, whose radius will be 3 centimeter. So one circle is there, you want to find locus of point which is always at a distance of 2 centimeter from this circle, blue circle, which is 5 centimeter radius. So you draw another concentric circle with radius 7. Each point over here is at a distance 2 centimeter from this given circle, and inside circle also, children, it's 2 centimeter. Okay, I'll draw the locus circle with under given condition in the dotted line. So this is the basic idea. Now we move on to the main thing of ICSE, point number 2 and 3. This was an introduction, children. So point 2 and 3 I'll explain, and maybe 2, 3 ICSE sum I'll do in this video, part 1. Then part 2 another 2, 3 sum I'll do, and part 3. So I think, and maybe one video where we'll do all the latest questions. But last few years during COVID time, I think Loci was out of syllabus. So this is the basic concepts, but now we will start this 2 particular thing in syllabus. I'll explain, then we will go to the ICSE questions. So before I go into detail, just I'd like you to all of you to see, if you see the syllabus, so loci comes under geometry. As I told you, locus is a moving point under certain condition. So introduction was all about it. It's a moving point under certain condition. Now if you see, there are 3 things. So here if you see, I had written locus and its construction, children, means you need to construct also. You need a compass to construct also, you need a pencil. So locus is just not about a theory, you have to draw. So this chapter, in some time, some books, it's called locus and its construction. Now there are 3 things. Locus definition, meaning I told you. Theorem, just I am going to tell you now. Okay, construction based on loci. Number 1, locus of point, which I talked about circle. You can see locus of a point at a fixed distance from a fixed point is a circle. Fixed distance from a fixed point, that center, fixed distance is called radius. Now point number 2 and 3, which I'll talk about, is if you see the syllabus, I'll explain. Okay, point 2, 3 is very important. All the ICSE question comes in that, and we will see there is an overlap of 2 and 3 in most of the ICSE question. 2 and 3 overlap. So I'll try to show you at least 2 sum in this video, where we will see the second and third concept is overlapping. Let us see next one, second thing in the syllabus. So I'll try to explain to it in a very simple language. Okay, what it is, you see. So this whole chapter is all about 2 things what I am going to tell you. Point number 2, suppose you have an angle. Okay, if you have an angle, children, so before I go to the locus part of it, so angle, you know, you draw with a protractor or with a compass. So first I'll tell you what is an angle bisector and how we draw it. So angle bisector is, here you take an arc, children, a fixed arc, and if it's 4 centimeter like that, you cut an arc over here. From here, take an arc and cut. Again you put your compass over here, one line here and one line here. When you join this, children, this dotted point is called the angle bisector. Once more, one given angle is there. Suppose it is of 30 degree. This full angle is 30 degree. So I have to draw angle bisector, means this line will bisect, means divide the angle into 2 parts. So how we do? Once more, you take a fixed radius, draw with the compass one arc, put again here. First you had put it here, the end, and next you put here, cut here, and then from here you cut. Where they cut each other, from this point we join that line, and this is called angle bisector. Now locus, what is important here? Any point over here, children, listen carefully. Let me call this point as O, this is A, this is B. So any point I am taking, let the point P, any point over here, children, Okay, listen very carefully to my wordings. Any point on the angle bisector, okay, I call it second angle bisector. Any point on this line is always equidistant. So like this P from two given lines. So P is equidistant from, very important word children, because next I'll show you perpendicular by, from lines AO, or you can take OA and OB. Once more, this is where we start the syllabus. I told you how we draw angle bisector. Angle bisector, take any point. Any point on the angle bisector is always equidistant. Equal distance means these two will be equal. Is equidistant from the line OA and line OB. Any point over here, P can be here, P can be here, and we have a proof also. So I'll give you proof. So remember, I'll come to proof. Let me tell you the second point also. Once more, any point on the angle bisector is equidistant from two given lines, children, OA and OB, any point over here. Next, third and last very important thing from syllabus is, suppose here, first I'll tell you what is a perpendicular. I call it, so this is perpendicular bisector in short. Okay, perpendicular, 90 degree. How we draw, children? First thing, perpendicular bisector is, let me make it little smaller. Take more than half. Suppose this is, children, 7 centimeter line. Take more than half. Take more than 3.5, 4 centimeter. So from here, cut an arc above, cut an arc down. It should be more than half. From there, you take cut an arc here and cut an arc here. So what you will see, children, when you join this point, this you may have done in your previous classes. If you have not done, please learn it. Once more, we have given point A and B. We have to find perpendicular bisector of AB. So we take more than half. Okay, so as I said, 7 centimeter. I take more than 3.5, 4 or 5 centimeter. One I cut above, one down from this point. From here you take above and down. Where they meet, you join a straight line. That line is called perpendicular bisector. Means that line is perpendicular 90 degree and bisector means these two are equal to each other. Once more, what is a perpendicular bisector? There are two words, perpendicular and bisector. Perpendicular means 90 degree and bisector means cutting equally. Remember, this was angle bisector. This line was cutting the two angle into two equal half. One angle into two equal half, and here we have one line cut. So this will be, children, 3.5. This will be 3.5. Once more, take arc more than half, one above, one down from here, one here and one down. Okay. So this is perpendicular bisector. Now what is the second and the last important thing about our ICSE syllabus? Number one, I told you point P is equidistance from lines OA. Remember this word, lines. OA and OB, and here suppose a point P is there, again I take P is generally, it is equidistant. So any point on the perpendicular bisector, here P was on the angle bisector, any point on the angle bisector, any point on the perpendicular bisector will always be equidistant from point A and B. So P can be here, children, P can be here also. So what is this? P is equidistant. Equidistant means, children, equal distance. P is at an equal distance. This can be suppose 5 centimeter. This is also 5 centimeter. P is equidistant from points A and B. See the difference over here. Okay, see once more before I take one or two sum. P is equidistant from lines OA and OB. P is equidistant from points A and B. From point, here I have a point. From these 2 points means here AP is equal to BP. This distance. So this point is equidistant from these 2 points, children, and this P is equidistant from 2 lines. So angle bisector, remember, equidistance from 2 lines, and perpendicular bisector is equidistance from 2 points, children. So if you remember this 2 point, then ICSE question is nothing for you, and I will show you by many example. Most of the ICSE question is based on both condition, so you need to do at least 5 to 10 years ICSE question. Okay, so just pause the video and copy, then I'll give you proof why it is true in short. I'll not go to the detail of the proof it is given. We use congruency. One I think is SSS rule and one is RHS rule. So kindly pause the video and copy. This is the main thing after introduction, and this idea we will use to solve all the question, almost all the question of ICSE. Maybe exception can be 1 or 2 questions. So please copy, then we will go to a short proof, and then we will do ICSE question. So just I'll discuss in short the proof of this. So kindly see over here. This is given that this point P is equidistant from the line. So let this be M, children, and this be L. So PM, this you will get in any standard book, just I'm explaining in short, provided you know the idea of congruence. PM is equal to PL, given this point is equidistant. I have to show that it lies on the angle bisector. P lies on angle bisector, this is given. So this is equal to this, given that this point P is equidistant from 2 lines. So PM lines are OA and OB. So PM is equal to PL. Next, children, this is 90 degree by construction, and this hypotenuse opposite to 90 degree is your hypotenuse. So this is hypotenuse. So by RHS rule, okay, so we have a 90 degree, you can write P MO is PLO is 90 degree, and we have OP common. So once more, hypotenuse is common. This is 90 degree. RHS rule, R right angle, hypotenuse and one side. RHS rule, both the triangles are congruent, therefore these 2 angles are equal. Okay, opposite to equal sides are equal angle, therefore this is the angle bisector. Okay, next here, this is given that this are equidistant. So we have to show that this point P lies on the perpendicular bisector. Then next, this is bisector, perpendicular bisector. So this is 90 degree anyway. We have to show that this will be 90 degree. You cannot take this to be 90 degree. These 2 are equal. This is common, children. And this being perpendicular bisector is by construction, okay, they are equal. So by SSS rule, side, these 2 are equal. This is common. These 2 are equal. So now these 2 angles are equal, and they are equal to, let it be x plus x, and this is the straight line angle. We know both the triangle are congruent by SSS rule. S, this 2 side, this is common, and these 2 are equal. Okay, so these 2 angles are equal, and the sum is 180 degree. So 2x is 180, we get x as 90, means point P lies on the perpendicular bisector. Okay, so this is the proof anyway, but remember those proof and all are not required generally. So remember once more, before I take one ICSE question to explain both, that if a point P is there which is equidistant from 2 lines, children, 2 lines, this will become clear when I do few sums. Okay, from OA OB. So angle bisector, the point is equidistant from lines, and in perpendicular bisector, any point, it is equidistant from 2 given points here, A and B. So kindly pause the video and copy. This is the main thing. Then we will do one sum to understand this. Now children, I take one sum, ICSE 2002. explain this concept of loci, and this example is one of the best examples. So see here, this is a 3-mark question. First you have to draw a triangle, children. This is a construction. You have to draw a triangle, then you see what we have to do. So how we go about it, children? Always draw a rough diagram, children. This angle is 60 degrees, so you draw a line 7 centimeter. So rough diagram is always useful. Draw AB. Here you know how to construct a 60-degree angle. Take compass, cut it for first time. Okay. This you produce, cut 8 centimeter here, name it C and join it with A. So this is my rough diagram of this triangle, and it will give you 1 mark, 60 degree. So let us draw. So once more, take a line AB, 7 centimeter. Okay. Here you draw an arc and cut it once from here. I think all of you know this angle is your 60 degree. Okay, you produce it and you cut 8 centimeter. So this point I call it C. You join with A. So this gives you 1 mark. So triangle ABC, once more, AB is 7. Draw 60 degree at B. Angle ABC is 60 degree and BC is 8. Now first condition, P is equidistant from BC. See, I told you one point will be there, P, which is equidistant from 2 points B and C. So just refer to my previous part. We draw an angle bisector. What I do, children? 8 centimeter, take more than 4, maybe 5 centimeter. Take 1 arc here, 1 arc here, cut. So if you draw perpendicular bisector, okay, so from here take more than 4, cut this side, cut this side. From here cut this side, from here cut this side. So this is perpendicular and bisector. So point P anywhere on this perpendicular bisector will be equidistant from B and C. These are the two things in ICSE. One perpendicular bisector, next you see. P is equidistant from AB and BC. P is equidistant from this two line. So we take angle bisector. What an easy thing. Already we have 60 degree angle. Just bisect it. Keep here, cut here and keep here. Your compass, cut here. So you'll get a 30 degree angle over here. This will be your angle bisector. So P is at the intersection of this. So I told you most of the ICSE question generally, not all, is where we use both perpendicular bisectors. So P satisfies both conditions, children. It is equidistant from point B and C. P is equidistant from point B and C. Since P is on the perpendicular bisector, this is 90 degree, these two are equal, and P is equidistant from AB line and BC because P is on the angle bisector. So P satisfies both. It is equidistant from B and C, and P is equidistant from, since it is on angle bisector as well as perpendicular bisector. Perpendicular bisector means equidistant from 2 points, and since it is on the angle bisector, it is equidistant from AB and BC. And finally they say measure PB. I think in reality if you measure, I think answer should be 4.5 centimeter. So you measure and record. So 3 mark question, 1 mark generally you will get up for triangle, 1 mark for locating this point, maybe with 1 mark for angle bisector, perpendicular bisector, or you get P, and the final mark you get for measuring this distance PB. So 3 or 4 mark. If it is 4 mark, 1 mark for triangle, 1 mark for drawing the perpendicular bisector, 1 mark for angle bisector, and 1 mark for this. So remember once more, very good question to understand the full. So this is basically what we have in ICSE, children. Once more, you draw a triangle from 2 points, draw a perpendicular bisector, P is equidistance from B and C, since it is on perpendicular bisector. P is on angle bisector, it is equidistance from line AB and line BC. So this was introductory lesson where I took a very nice question, ICSE 2000, where we understand the concept of loci, children. So kindly pause the video and copy, and then next video I'll take up 3 or 4 more ICSE question in part 2 and part 3 also, then I hope. And if you see the solved example and try unsolved example, you will be able to do this chapter. So kindly you first try to do all the ICSE question, because many books, they have a lot of things which are not needed for solving ICSE questions. So thank you children for watching this part 1 of our video lesson on locus.